Well, good morning, everyone, or afternoon, depending on where you are geographically. Welcome to the Raypak Digital Swimming Pool Heater Installation Seminar. We're going to take about an hour to talk about the proper installation of this gas burning appliance. My name is Brad Duncan. I am a product specialist and trainer with Raypak. As a reminder to all our participants, the instruction provided in this training is intended for qualified and experienced professionals. If you're not qualified, please do not attempt to apply these instructions on your own. This is our Raypak digital swimming pool heater. This is the one we're going to be talking about today. Properly installed and maintained, your customer will enjoy many years of reliable performance from this product. As you can see, it comes in four sizes. Models in four sizes ranging from 200 to just almost 400,000 BTUs. And as you can see, the model numbers correspond somewhat with the BTU input. Here we took the door off so we can give you a little tour of the appliance. We are certified for combustible flooring. You can set this thing right down on plywood if you need to. Our burner tray is down here at the bottom. This heater is at its essence a fire at the bottom with water at the top. Soft opening gas valve here for a nice controlled ignition. There's a heat barrier here that will, I've lost an arrow somehow. There's a heat barrier here that will keep the heat downstairs where it belongs. Up top front center there is our control panel for ease of access. This is where you would operate the heater. In this junction box here is a 24-volt dual tap transformer. This particular unit pulls 4 amps at 120 volts or 2 amps at 240 volts. So now this means that your conduit would come up on the right side of the unit upon installation. If you need to run your conduit up on the left instead, there is an identical alternate junction box on the left-hand side. So you would take your transformer out, move it over to there, and pull the wires back across to the board accordingly. This way you don't have to run your high voltage wires behind the PC board. All the wiring is color coded, so we know exactly what the wire is, where it goes, and what it does. There is a rollout switch for safety down at the bottom, so if we have fire coming up the front instead of on the inside, it'll shut the heater down. And of course, our bonding lug is located right here. This heater, and indeed any gas burning appliance, has certain requirements for proper operation. Water flow rates, gas flow rates, combustion air, electrical input, correct ventilation, things of that nature. If you install it wrong, it won't work right. A large percentage of the failure rates we see can be attributed to substandard installation. A properly installed heater works better and lasts longer, and that keeps your customers happy. We're going to break down the installation by topic. I'm going to start with water, then we'll move on to air, gas, and electrical. So starting with water, after positioning the heater in its permanent location, you'll plumb the incoming water line from the filter to the left side port. There's an arrow at the top of the inlet so you don't forget. Don't plumb it backwards. In on the left, out on the right. It sounds a little simple, and it is, but you would be surprised at the number of these that we see that are just plumbed wrong. In order to achieve maximum performance, the rate of water flow through the heater should be within parameters. Minimum rate varies by model, starting at 20 gallons per minute for the 206 and up to 40 gallons per minute for the 406. All models max out at 100 gallons per minute. Now, if your system is moving more water than that, we would strongly suggest using an external bypass to divert some of that water around the heater. Or if you're using a variable speed pump, you may be able to make the adjustments necessary to the programming of the pump to maintain water flow within these parameters. Without a flow meter, you don't really know how much water is flowing through the heater. Now, there are many types on the market. You choose the one you like. Just make sure it's installed according to the manufacturer's specifications on how and where to install it. and by where, because I'm about to show you the ideal where, but the manufacturer may have limitations based on the distance before and or after the distance to a fitting like a 90. All right. Here's one example of a manual bypass. This is basically just a pipe that runs between the inlet and outlet pipes that allows water to bypass the heater. How much water bypasses can be controlled by a valve on the bypass. You'd want to install one of those. You might also choose to install isolation valves on the heater side of the bypass. This would allow the circulation system to function in the event of damage or service to the heater. So if you needed to disconnect the heater entirely without shutting the system down, you could do that if you have isolation valves and the proper unions installed in the proper locations there. Your flow meter should be positioned between the bypass and the heater. Putting it elsewhere might only tell you the flow rate on the system and not the flow rate through the heater. Let me show you what I'm talking about here. If you put the flow meter back here or down here, you would know, the flow meter would tell you what the flow rate is on the entire system. It doesn't tell you how much water is actually just going through the heater. So if you have this ball valve open somewhat or all the way, and you put the ball valve or put the flow meter here or here, wouldn't really matter. You would have virtually no water flowing through the heater, and your flow meter would not tell you that. So you want to put them here or here. All right. So you can see this is inside the loop that goes to the heater. So we're watching the flow meter to tell us how much flow is going through the heater itself. Here's another configuration for a bypass. If you use this one, the ball valve is on the main line here. So in order to push any water at all through the heater, that valve will have to be at least partially closed. Wide open means no water running through the heater. Completely closed means all the water flows through the heater. And again, positioning of the flow meter is important. There are many factors that influence rate of flow, but the pump is the most important. If you're working with a variable speed pump, flow rates can be adjusted from there. Just make sure that all the programs fall within acceptable flow rates. Now, bear in mind that at the lower end of the parameters, you might find a flow point at which the heater pressure switch will close, but there's still not enough water running through the exchanger to cool the tubes sufficiently. So then the water gathers too much heat and the high limits strip the heaters off. All right. During setup, run the heater with the pump at the lowest speed programmed for 10 or 15 minutes to make sure that that does not happen. And then do that same test with the plumbing set to the spa. Remember, the hydraulics are different on the spa. Now, this is our pressure relief valve. The National Fuel Gas Code requires a pressure relief valve if you have anything downstream of the heater that might restrict flow. In fact, the code specifically uses the word nozzles. Okay, eyeball fittings in the plaster might be considered nozzles. The PRV is provided with the ASME model in order to meet ASME compliance. It's not an ASME without a PRV. All right. We do, however, we don't provide the PRV with the polymer residential model, but we do provide a port for installation in case you need to put one in. This port has a threaded plug that can be removed with a 1/2-inch drive socket wrench. For safety, piping should be installed after the PRV and oriented downward, terminating around 6 inches from the floor or as required by local code. Avoid using PVC for this, as heat transference can warp PVC pipe. This is for safety, so that the pressure switch, or the pressure relief valve does open up and allow hot water to spray out, it won't be spewing out horizontally. It will be facing the ground so that it will just flow out onto the deck there. Every effort should be made to ensure that the plumbing is as straight as possible, using as few turns as possible. Sweep 90s are far less flow restrictive than hard 90s, so use those as much as you can. Restrictive plumbing affects everything in the system. Your chlorinator might not work as well. The pump uses more energy to move the water. Reduced flow means longer turnover times and slower filtration. Increased pressure on the system could slow the water to the heater, reducing pressure at the header and causing premature shutdown. Okay, that is nuisance tripping of the pressure switch. Take a look at this. This is a clean filter. I know it's a clean filter because I'm the guy who cleaned it. Okay, the elevated tank pressure is due to plumbing restrictions. All this spaghetti. Take a look at those hard 90s going into the backwash valve. Those are extremely restricted. So shorter filter cycles mean more pressure switch nuisance shutoffs. Okay, if you look really closely at that pressure gauge right there, you can see that this clean filter is actually running about 28 pounds PSI, and that's pretty high. At that point, we're within probably 5 to 7 pounds of having the heater shut off because there's just not enough flow going to it. This loss of flow causes the pressure switch to open and shuts the heater down. The pressure switch is there to ensure that there is water flowing through the heater. Typically, the heater will operate safely when there's enough flow to generate 1.75 psi. That's where we set the switch at the factory. This is assuming that the heater is installed at or near the water level. Up to about 5 feet above or below the water surface, you can adjust the pressure switch as necessary to require more or less pressure to close. If you're installing 5 or more feet below the water surface, you'll need to install either a higher rated pressure switch, which we do have available from Raypak, or a flow switch. If you're 5 feet above the surface, only the flow switch will work. All right, here's why. Down here, I can use a pressure switch that is an elevated pressure switch. You know, we're 5 feet below the water here. The weight of the water in the pipes could be enough to close the pressure switch. So if the pump fails, heater doesn't know it, and it will dry fire. So we could use that higher rated pressure switch, or we could use something called a flow switch, which closes under flow and not under pressure. It's just making sure that the water is actually moving. Bear in mind that if you're up here on an elevated installation, the water that came up to the heater has to turn around and come back down to the pool. As it falls through the pipes, the gravity acting on that water can actually start to be, provide more pressure, or, pulled down faster than the pump is moving water through it. So now it begins to offset the pressure up here. So even though you have perfectly good flow up there, nice strong flow, you could have no pressure or even negative pressure up here where you need it. In this circumstance, a higher rated pressure switch won't do you any good because we're not getting any pressure. What you would need there would be a flow switch. Here's an example of where a flow switch might come in handy. Again, the weight of the water in the pipes could easily create enough pressure to close that switch, and if the pump fails, the heater can drive fire. Turning this adjustment wheel clockwise will cause it to require more pressure to close, as might be necessary when the heater is located below the water level. Which means, of course, that turning it counterclockwise causes it to require less pressure to close, like for an elevated installation. All right, let's talk about air requirements. When we talk about air, we're mostly talking about indoor installation, but there are some safety issues that are involved with outdoor installation that have to be addressed. Per National Fuel Gas Code, the point from where the flue gases exit the heater must be 4 feet below or horizontal to any door, window, or inlet to a structure. If it's closer than that, the point of exit must be at least 1 foot above. So, 4 feet below or horizontally or 1 foot above any door, window, or inlet. That means if you're within 4 feet below or to either side or in front of a door, window, or inlet, if you're within that space, you have to be 1 foot above that door, window, or inlet. Now, that applies unless the opening in question is a forced air inlet that actively draws air in. Then the flue gas exit point must be 10 feet below or horizontal to or 3 feet above. All right, this is all for safety. Okay, this is just so you don't expose people inside that structure to noxious fumes. And by the way, this ain't a Raypak thing, guys. This is a safety thing dictated by the National Fuel Gas Code. This applies to any swimming pool heater. Not that you'd install someone else's heater, God forbid, but just so you know. Indoor installation has certain requirements for air. The heater needs both combustion and ventilation air. You can't have a fire without air. That air must be provided through an opening at the bottom of the wall. You can see down at the bottom of this wall here where it says combustion opening. All right. As the heater burns, hot exhaust is created, which is vented from the room through a vent duct. The gases rise by convection, creating a pull or a draft. Now, this creates negative pressure within the vent, causing combustion air to be pulled in too quickly, disrupting the flame and causing problems, most notably soot. We can fix that. We can relieve that negative pressure by providing an indoor stack kit. The indoor stack kit must be included with any indoor installation. It's sold separately. The best bet would be to just order it at the counter when you order the heater, because they are sized to the heater. So 4 sizes of heater, 4 sizes of vent stack. The vent hood allows air relief air to be pulled in without disrupting the flame below. Here's how that works. We've still got fumes pulling air up, okay? Those fumes are creating a draft, only now that draft is pulling air in from underneath the hood instead of underneath the heater. So we've solved that problem. But in doing so, we've created another problem. We're pulling all the air out of this room. I mean, quite literally sucking the air out of the room. That air has to be replaced. That air is replaced through a ventilation opening at the top of the wall, there where it says ventilation opening. That's sometimes referred to as replacement air. This is just so we can have air in the room. The sizes and locations of these openings are dictated by the National Fuel Gas Code. NFGC says 1 square inch for every 4,000 BTUs commencing within 12 inches of the floor and 12 inches of the ceiling. So 2 holes, 1 at the top, 1 at the bottom. Now let's say we've got a Raypak 406, that's a 400,000 BTU unit. 400,000 divided by 4,000 is 100 square inches. That's a 10 by 10 hole. 2 holes, both should be 10 by 10. Now, you will not likely see, it would be very rare for you to see these holes in the wall that are not covered in some way by either typically louvers or screens, or sometimes even both. Those louvers and screens restrict airflow. So the only way to compensate for that is to have a bigger hole. So if they are louvered or screened, you will add 50% to the size of the hole. If it's louvered and screened, you will add another 50% to the size of that hole. All right, so your original 10 by 10 hole is now a 10 by 20 hole, just to accommodate the needs of that heater. Two things that you should know. First of all, it will be unlikely that you will be allowed to modify that hole. Okay, the building is probably not going to let you, go out to your truck and grab that Sawzall and cut a hole in the wall or a bigger hole in the wall. More likely, the size of the heater will be limited by the size of the hole in the wall. Something else to bear in mind is that, in this example, we just got one heater in the room. What if there's more than one heater in the room? What if you got one for the pool and one for the spa? What if you've got a boiler in there? What if you've got a hot water heater in that room? All gas burning appliances in the room must be accommodated. So you'll have to look at the rating plates for all of these appliances and add up the BTU input to determine if you have a big enough hole in the wall. If you're installing a heater in a room with a fan that pulls air into the room, that's called forced air ventilation. Generally, you would need an HVAC technician to determine if the fan pulls in enough air to accommodate the gas burning appliances in the room. In fact, in some areas, local or state codes may require a ventilation specialist to document compliance. So that's HVAC work right there. Often you'll find swimming pool equipment installed in an outside structure or a shed. That is still an indoor installation and requires a vent hood and correctly sized air intake openings, not only for the sake of proper performance, but for safety. We don't want anyone using this small space to suffer from inhalation of fumes. All right. Most likely, looking at this, I would say most likely someone put the equipment in and then installed the shed around it. But that's just something you have to look out for. The guy that built the shed doesn't know anything about swimming pool heaters. He's not the professional. You are. Circumstance like this, modifications would have to be made. As the flue gases travel through the vent, they begin to cool down. If they cool down below 132 degrees before they get out of the vent, condensation begins to form on the inside. The resulting condensate not only rusts the galvanized steel pipe, but because it's very acidic, it can damage other parts of the heater if it runs back down. So it's important to get the gases out of the flue vent before they cool below 132. We want to avoid anything that would slow them down. All right. Listen, the laws of physics tell us that, on this planet, those fumes are going to get below 132. It's going to happen. They're not just going to stay at 150 degrees or whatever they are. So we know it's going to happen. We just want it to happen outside. We want it to get all the way out of the vent pipe before this occurs. So it's not a matter of trying to change physics here. It's just a foot race. That's it. We're just trying to get the fumes out as quickly as we can. So we want to avoid anything that would slow them down, things like oversized venting. If the gases have room to expand horizontally, then they won't move as quickly vertically. We want the gases moving upward steadily and quickly. Undersized venting is a problem. If the vent is just too small to accommodate the gases being produced, they won't get out of their own way. Now, this leads to internal condensation as well as other issues like rollout and sooting. Now, here's some problem venting. First of all, it's downsized, which is a problem. But look at the horizontal portions. Convection pulls hot gases upward, not sideways. Hot air rises. So there's nothing to pull the fumes horizontally. You can use horizontal venting, providing that the rise is 1/4 inch per foot. So for every 4 feet of vent pipe, the downstream end must be 1 inch higher than the other end. This way, the flue gases always have an upward path to travel. There may be installations where, because of the length of the run or other factors, the heater can't be sufficiently vented without help. That help is called a D2 power vent. you can think of the D2 as a pump for heater fumes. Flue gases are forced out through a smaller 4-inch duct. This means that you now have positive vent pressure, and your venting must now be category 3. That's a stainless steel vent pipe with sealed seams all the way from the D2 to the termination point. By that I mean it has to go all the way to where it's exiting outdoors. You can't just run that 4-inch pipe up to the hole that was already in the ceiling and then expand it from there. It doesn't work that way. All right. These come in 4 size models, 2 smaller sizes, 2 larger sizes. Each size comes factory wired either 240 or 120. So this gives you 4 different part numbers. You can change the voltage in the field if you have to. I mean, obviously the easiest way to do it is to order the one that you need in the voltage that you need. But if you find a circumstance, as might be the case, where a 120, for instance, is not available at your distributor because they just don't stock them, so it's a special order. They don't stock them because they don't get a lot of call for them. 240 is kind of the standard, so you don't really see a lot of 120 much. But if you need one and they don't have one, you can rewire it 120 to 240. There's an explanation in the instructions that come with the D2. I'll tell you right now, it's a little vague when you're reading it. You come across something like that, you give me a call, I'll tell you how to do it. Okay, rolling along, let's move on to gas. Now, these are the gas line requirements. The larger the heater size and the further the distance from the regulator, the larger the pipe diameter must be. You can't expect to deliver enough gas to a 400,000 BTU heater using 50 feet of 1-inch pipe. Okay, pipe's just not big enough to move the type of volume that you need. This is just physics. All right. You will find that these distances and sizes are similar across all heater manufacturers, as they are related to NFGC guidelines. There's some minor differences, but they're all pretty close. You may find that the size of the heater will be dictated by the size of the gas pipe. You can try a smaller sized heater, or if local codes allow, you might be able to increase the pressure in the pipe and regulate back down using a second regulator at the heater end to convert that pressure to volume at a pressure that's appropriate for the gas valve. So this information is going to be in the manual that comes with the heater. Take a look at your gas line that's on the property, determine the size of the line and the distance back to the regulator or meter. Okay, so if you look down, you see a 1/4-inch line, you're running natural gas, you got a 406 and it's 50 feet. Okay, you're cool. 406, 1/4 inch, I'm sorry, 1.25 inches will take you 95 feet maximum. Now, if it were a 1-inch pipe and you had 50 feet back to the regulator, you couldn't run a 406. It'll only accommodate up to 20. Even a 336 wouldn't do. It'll only go up to 30 feet. You'd have to drop all the way down to a 266 for that application. Once again, pipe may in fact be a significant factor in determining whether or not you can install a heater of that size. This is that secondary regulator I was telling you about, but it should be outside the cabinet because it's equipped with a pressure vent that can release gas into the cabinet, which could ignite. All right, so we want that. This is just another secondary pressure regulator. We want that outside the cabinet. This is your gas cock. That should also be outside the cabinet where a user can find it and shut off the gas in an emergency. You are supposed to install those by code. There should be one within 6 feet of the heater. We're going to ask you to put it outside the heater within 6 feet. The use of a flexible gas line is not recommended. They are restrictive, they're noisy, and the right size is rarely used. Most people just use the size of flex that matches the incoming pipe, which is usually 3/4 inch. But the ANSI says that that should only accommodate up to 114,000 BTUs. We don't make a heater that small that burns gas. Well, I take that back, we do. On our other models, not these, but the 106, 156s, you might be able to run one of those if you had to. So now you could drop down to 1.25 inch and use that. That'll run you up to 430,000 BTUs. But if you think about it, that 1.25 inch is going to be way more expensive. These things are stainless steel on the inside. Okay, so they're already expensive. The 1.25 inch just makes it a lot more expensive and a lot less flexible, and therefore far less convenient. We're going to recommend just using rigid pipe right up to the gas valve. This is a sediment trap. They are mandated by the National Fuel Gas Code to be used on every installation. Sediment and dirt, rust of that, things like that can be pushed along by the flow of the gas inside the pipe. The idea is to capture that sediment before it gets to the gas valve. Sediment can accumulate inside the valve and cause it to fail. And if you've ever had to buy a gas valve, you know that they are not inexpensive. So it's important that the gas be traveling downward and then turn toward the heater just before the trap. This way you have gravity and momentum working together to capture the traveling sediment. The gas valve is designed to accept pressures within a certain range. The gas leaving the valve on the way to the burners will exit at a set pressure. So if the incoming range is correct, the outgoing range will be also. Upon installation, check these pressures with a manometer. A manometer is an instrument for measuring pressure acting on a column of fluid. If you plan to install or work on gas-burning pool heaters, you should have a manometer. This device measures pressure acting on a column of water in increments referred to as WC, okay, increments in water column. There's just under 28 inches WC to 1 pound PSI. So just 1 pound PSI is 27.7 inches water column. So we're only talking about small amounts of pressure here. That pressure is there only to drive the volume of gas. There are 3 main types of manometer available. The slack tube manometer on the left is the standard, as it actually has water in it for the gas to push upon. In the center is the dial type. It's a spring-loaded device, works a lot like the pressure gauge on the filter tank. On the right is the digital type. They are considerably more expensive, but they measure in much smaller increments. As you can see, this one goes down to 1/100th of an inch water column, far below anything we would need on a device like the one we're talking about today. Something that might be more appropriate for a commercial-sized heater that needs a more narrow band of pressure. All right, choose the one you like. Use the one you find that's appropriate for you. They should all come with tubing to complete the distance from the test port to the manometer and a fitting to adapt the hose to the test port. The test ports are located on the gas valve, one on the supply side, one on the manifold side. The Allen wrench necessary for removing the plugs are often included with the manometer. If you have a manometer and it didn't come with the Allen wrench, or you misplaced that, it's just a 3/16 inch Allen wrench. Make sure you've got one. There are 3 measurements to be taken. The static pressure is taken before the valve without flow. This is just the pressure of the gas standing in the pipe. This is like checking the air in your tires, okay? Don't remove your manometer yet, because now you're going to fire the heater and take the dynamic pressure. This is taken before the valve with flow, the pressure while the heater is burning. All right, obviously you're burning some gas now, so you're sapping some of that pressure off, which means your dynamic is going to be lower than your static pressure. All right, now you need to remove your manifold, cap that port off, and move the manifold to the other side to take the manifold pressure, which is taken with flow after the valve. This is the pressure of the gas going to the burners, okay? If you give us the right numbers coming in, we'll give you the right number coming out. That number coming out is already preset at the factory. Now remember, the heater might run with incorrect pressure. So the day you put that in, you fire up the heater, it turns on and runs. Hey, it's great, I'm done, I'm out of here. I got to move on to another job. Well, you know, if you don't really know if you're quite in the right spot unless you test them. And you're going to get problems over time if you have a pressure problem. Okay, so check the pressures upon installation. At least you can say the day you installed it, it was correct. And whatever happens to that gas line after you're gone, that's a different story. We don't really know what someone can do. People will install other gas appliances and tap onto the line because they don't know any better. All right, you see this a lot with things like gas grills and fire pits, stuff like that. Those things sap gas off the line and can easily pull your pressure down to beneath that which would be sufficient for your heater. And again, here are your pressure guidelines. You guys are primarily natural gas. We see ATM, that's the atmospheric model that we're teaching in this class. We offer a low NOx model for use in certain parts of the country. It just has a slightly different pressure on the manifold side and slightly lower acceptable pressure on the inlet side. Moving on to electrical. Now, we burn gas to create heat, but we still need electricity to operate the heater, power the electronics, power the gas valve, things like that. Now, like most pool heaters, in fact, all of the ones that I'm aware of, we need 24 volts AC. Since there is no 24-volt AC plug in the wall, we need to create that 24 volts using the power that's available. We'll accomplish that using a step-down transformer. During installation, the transformer is wired to the incoming voltage, either 120 or 240. This is a dual tap transformer. After wiring, no further action is needed to accommodate voltage. So don't bother looking for that, wiring harness or the adapter clip, and this one's red and that one's black. We don't need this. This particular model just doesn't use anything like that. Once you've wired it up, you are good to go. Straight from the box, the transformer wires will be protruding from the side of the cabinet. There's a red sheet of paper attached there with wiring instructions on it. There are 3 wires on the primary side of the transformer, white, red, black. On the secondary side, that's the 24-volt side, there is a blue and a yellow. There's also a green wire that attaches to a ground screw on the cabinet. You will be wiring on the primary side. Now, whether you're wiring for 120 or 240, the ground is the same. You might as well go ahead and wire that first. So we're going to wire up our ground to the incoming ground from the panel or sub-panel. Now, if you're wiring 240, well, now we don't need that neutral wire. That white wire is our neutral. We don't need that on a 240 circuit, so we're going to go ahead and cap that white. At this point, you have 2 wires left coming off the transformer and 2 wires coming out of your conduit. The 2 wires coming out of your conduit are your hots. Those are your hot wires. You will wire one of them to the red and the other to the black. Now, if you're wiring 120, okay, now we need that white wire. That's our neutral. Okay, this time there's one of the other 2 that we don't need, okay, because we don't have enough wires to go around. It's the red one. Cap the red wire. You don't need that one. And your white, of course, goes to your neutral. And your remaining wire is your hot, and that goes to your black. Properly wired, you're going to have 24 to 29 volts coming out the other side and plugged into the board. Check the voltage at the installation point to verify that it's in range. Occasionally, you may find that the voltage on your 240 line is actually 208 volts. This most likely means you have 3-phase electrical. This is often found at commercial buildings. I've seen this at apartment buildings. I've seen it at health clubs, that sort of thing. Do not wire the heater for 240 operation if the incoming voltage is 208. Low voltage in means low voltage out. So now you have perhaps less than 24 volts going to the board. You're looking at a weak spark, you could burn the transformer. Your gas valve may not open properly or all the way or at all. One solution to this problem is to wire the heater for 120. On a three-phase system, each of the two hot wires are still 120 volts each. So if you pull in a neutral wire, you can cap off one of your 120s and use the other for the hot leg of your 120 circuit. All right, so now we have a ground, a hot, and a neutral. That's a 120 circuit, and we can wire the heater 120 instead of 240. Now, your other option would be to wire in a different transformer that can accommodate 208. If you choose this option, just be aware that it could potentially affect your warranty. There's a lot of cheap transformers out there, guys, and if you buy one of them and you put it on the heater, if it fails and takes out another component, we may not be able to warranty that component. All right, just bear that in mind. Look, don't waste time with cheap stuff, man. Why give yourself another headache? Get quality equipment. If you're going to get something like that, make sure you get a good one. Let's talk about remote operation. I get a lot of questions about that. Your modern operation systems have their own dry contactor for the heater and their own temperature sensor. They all work the same way. As far as I know, all the ones that I'm aware of work the same way. They monitor the water temperature on their own, and when heat is necessary, the contactor closes. Okay, here's what that looks like. Temp sensor for the automation system. Here's your contactor for the heater. Okay, important for you to understand that your automation system doesn't know what a swimming pool heater is. It doesn't have the first clue what a swimming pool heater is. The only thing it knows how to do is determine the temperature of the water, decide if there's a call for heat, and close the circuit. It just closes that contactor there. That's the only thing it does. When the the temperature of the water gets up to a certain point, a set point, it opens the contactor back up again. That's it. Now on our board next to that 5-amp fuse, you will find our dedicated remote circuit. It's a wire harness with 3 wires and a label for identification. The blue wire is hot, and it will be live with 24 volts when the board is powered. The other 2 wires, an orange-black and a black-orange, will determine whether the heater turns on in pool or spa mode. Doesn't matter which one you pick, just pick one. Now, you'll need a length of wire to span the distance from the heater to the automation system with at least 2 conductors. Again, that blue wire from the board is your hot, so we're going to extend that and attach that wire to one side of the contactor on the remote. We'll choose one of the other 2 remaining wires. We'll extend and attach that to the other side of the contactor. So if you send a return wire to the orange with the black stripe, when the contactor closes, heater will turn on in spa mode. Conversely, if you use that black wire with the orange stripe, contactor closes, heater turns on in pool mode. The reason it doesn't matter is because pool and spa are just 2 labels. They're just 2 names for 2 different temperature settings. They'll both go up to 104. All right, so as a matter of fact, that's what we're going to do next. We're going to set them both up to 104. We need to tell the heater to pay attention to the automation system. So we're going to set pool and spa temperatures all the way up as high as they'll go. This is what fully enables the heater so it doesn't get in the way of the remote. If you set the temperature of the heater lower than the temperature of the remote, it won't matter. It will stop wherever the heater is set. So I mean, look, if you want to limit, the temperature on the heater, this is one way to do it. Now, using the mode button, we will select the off mode of operation. Then we're going to press and hold both up and down arrows simultaneously for 5 seconds to enable the remote function. The heater has just become a follower of the automation system at this point, and it will begin its firing cycle when the contactor closes. These are the minimum clearances for this heater. These clearances should be maintained to prevent damage or combustion of nearby surfaces and to facilitate maintenance and repair. Again, these are the minimums. In some cases, more is better. The water side, for instance, could use more than 12 inches if you can get it. You may have to take that header off at some point. You're going to need a little bit of room there. I would recommend at least 18 inches on the header side. Okay, the front of the heater needs to be at least 24 inches in order to get the burner tray out. And again, more if you can get it. Failure to maintain clearances makes the heater difficult to work on and can certainly cause damages to other surface. All right. You take a look at that one on the left there. This, again, is the sort of thing that happens quite often when someone comes after installation to put in a wall or some sort of an enclosure or a shed or something like that. The individual building that, item, whatever it might be, probably not a heater guy. So they don't realize that, hey, man, we need a little room to work on this thing. In fact, in this case, you need some room just to operate the heater. I'd like to take a moment to state Raypak's commitment to developing and producing sustainable products. Raypak and our parent company, Rheem, have established firm goals as we work toward substantial reductions in waste, both in our manufacturing process and in our entire line of products. As we work toward our vision of designing for zero waste, we've developed a strategic framework with specific target goals for 2025. We're committed to developing and innovating intelligent products that reduce waste over the lifetime of the appliance, including the use of recycled and recyclable materials. We will endeavor to reduce greenhouse gas by 50% and achieve zero waste to landfill in our global manufacturing operations. We will train 250,000 plumbers, contractors, and technicians on sustainable products, installation, and recycling best practices. Why does this matter to you? It matters because your customers want to buy products from a company that values sustainability. Our studies have shown that 84% of customers indicate they prioritize purchasing a pool heater from a brand that's committed to sustainability. And what can you do about it? You can let your customers know that environmental factors are important to you in your business dealings. Purchase products and materials from companies that take sustainability seriously. Consider investing in fuel-efficient work vehicles. Use paperless billing practices. Make sure the appliances you replace are properly recycled and not just tossed into a landfill. Hey, you can recycle the cardboard box that the new appliance came in. There's dozens of ways to embrace sustainability in your business, many of which can help profitability. We just hope you'll take the time to consider them. So write this phone number down. This is the number for the service department. This number is for you, the heater technician. It's not for the homeowner or building manager. There's very little that we would be able to do for them. Okay? They probably don't have a manometer, probably don't have a multimeter or anything like that would enable them to get the information that we might need to determine what their problem is. Issues with a heater that is already installed or being installed will be addressed by technical assistance. For help before installation, ask for applications. Now, bear in mind that the people on the phone don't know what heater you're standing in front of, so you'll need to know the model and serial number. They will also want to know if the installation is indoors or outdoors. They're going to want to know what kind of gas you're burning and gas pressures and voltages. When they ask, Please give actual numbers. Okay, they need a real number. They may ask you on the phone, what's the voltage here? What's the gas pressure there? Things like that. If you say something like, oh, the gas is good, all that really tells them is that you didn't check. We're glad you chose to sit in on this installation webinar. Don't forget to register for the third class on the Raypak Digital Series, Advanced Troubleshooting. Thanks for choosing Raypak products. Have a good day.